Hello everyone. In today's video, we will see 21st question in LeetCode, which is merging two sorted lists. So here you are given the head of two sorted linked lists, list 1 and list 2, and you have to merge them into one single sorted list. And here given numbers are 1, 2, 4 in list 1 and 1, 3, 4 in list 2. Now if I merge them in ascending order, 1, 1, 2, 3 and 4, 4 will be our answer. Now let's take another example and we will see. So here we have two lists. List 1 contains element 2, 4, 6 and list 2 contains elements 1, 3, 5, 7. Now if I merge them in ascending order, our output will be 1, 2, 3, 4, 5, 6, 7. Now, for any linked list, we need to have a head, right? And if I merge these two lists, I need a head. For that, what I'll do is I'll take a dummy variable, dummy node, and it can be any number, minus 1, 0, or any number you want. This acts as the head node. But since we cannot move the head, I'll take another temporary variable and it will point to the dummy node. Now we have created a node with element minus 1 and this will be the temp. Now what I have to do, I have to compare the first element of the list 1 and first element of the list 2, right? So for that purpose, I'll take another two temporary variables, TL1 which will point to list 1 and TL2 which will point to list 2. TL1 will point to the head of the list 1, TL2 will point to the head of the list 2. Now these two variables will move from one variable to another variable. So initially I'll compare 1 and 2. Which one is the smallest? 1. Now after that what I have to compare? I have to compare 2 and the next. See this is 1 here. The next element is 3. So I have to compare 2 and 3. Which one is the smallest? 2. So this is completed. Now which one I need to compare? 3 and 4. Which one is smaller? 3 is smaller. So this is completed. Now again I have to compare 4 and 5. Which one is smaller? 4 is smaller. So again I have to compare 5 and 6. Which one is smaller? 5 is smaller. So we'll do this till we find all the elements which are smaller and see 5 comma 6 5. Next 5 is completed. 6 comma 7. Which one is smaller? 6 is smaller. Now for this the list is completed. So there is another one single node in other list. So I'll add 7 at the end. This is how it works. Now the temporary variables TL1 and TL2 will be used to traverse the two linked list. Okay. So first what is the condition I'll check? If TL1 dot data is less than TL2 dot data. TL1 dot data. What is the element that is present at TL1 dot data? Which is 2. And TL2 dot data 1. Is 2 is less than 1? No. So there we cannot go into this condition. So we will write else part. So in else part, what I'll do? We already have a temporary variable, right? Which is pointing to dummy. So temp dot next should be TL2 because TL2 is a smaller value. Now, what is TL2? TL2 is pointing to 1500, which is the head of TL1. So I'll insert here 1500 and there will be a link formed which is having 1 and 2500. This location is 1500. Right. After this, TL2 is pointing here. Right. Now it should point to this location. So what I'll write the code? TL2 equal to TL2 dot next. So here I'll write TL2 equal to TL2 dot next. Now, similar way, if the TL1 dot data is less than TL2 dot data, then temp dot next should be TL1 and TL1 equal to TL1 dot next. Now, check this temp. So initially temp should point here. Now, if another element need to be added, it should be added in this location. It should replace 2500 and the whatever value that need to be stored here, address, have to be changed. So temp should be pointing to here, right? So in both the cases, if TL1 dot data is less than TL2 dot data, or otherwise TL2 dot data is less than TL1 dot data, both the cases, what we need to do, we have to change the temporary variable to the next one. So temp equal to temp dot next. Okay, and this process should be continued till which part? Either first list or TL1 becomes null or there is no node, or TL2 becomes null. In these two cases, we have to stop, or otherwise we have to repeat the same process, right? So here, while, because it is a repetitive process, I am using while TL1 not equal to null and TL2 not equal to null. So if I use and if one of it is equal to null, then I'll come out of this loop, right? Now let's traverse the program. So first, initially, we are taking TL1 dot data and we're comparing less than TL2 dot data, right? So here we already added 1500, right? From else part. Now TL2 equal to TL2 dot next. So what is TL2 pointing to? TL2 dot next, which is 2500. TL2 is pointing here. Now again I will compare TL1 dot data. What is the value here? 2 and TL1 dot data is having element value 2 and TL2 dot data is having value 3. 2 is less than 3. Yes. So what I have to do? Temp dot next. Temp dot next should be filled with TL1. TL1 is this node, which is 100. So here 1000. So here 1000 will be stored and it will point to 2 and the 2000 and here it is 1000. See, if you observe that in the node address I am storing 2000. That means here the address of the next node will also be stored. But whenever I am checking the condition, here what is happening? We are replacing this with some other value. After this, TL1 equal to TL1 not next. So TL1 will point to here TL1 because TL1's next is 2000. So that is the reason why it will point to 4. After this, we also need to change temp equal to temp dot next. So initially temp is pointing here. So now it will point here. Again, so TL1 is not empty, TL2 is also not empty. So the next value TL1 dot data, it has 4 and TL2 dot data which has 3. Is it satisfied? No. So we'll go with the else part. In else part, temp dot next equal to TL2. So here temp dot next should be having TL2, which is 2500. That is a node will be added 3. It has 3500 and this is 2500 location. And after this TL2 equal to TL2 dot next. So TL2 should point to, instead of this, TL2 should point to here And after this, temp equal to temp dot next. So temp will stop pointing here and it will go to 2500. So temp will point here. After this, again, is TL1 empty? No, TL1 is pointing here. And is TL2 empty? No, TL2 is pointing to this node. So again, we will check. What is TL1 dot data? TL1 dot data is 4. And what is TL2 dot data? It is 5. 4 is less than 5. Yes, 4 is less than 5. So temp dot next will be having TL1. TL1 is 2000. So here 2000 will be stored. That is 4. And it is having 3000, 2000. After this, TL1 will point to TL1 dot next, which is 3000. So TL1 will point here instead of this. And also we have to change temp equal to temp dot next. Instead of pointing temp here, temp is pointing here. Now let's compare again TL1 dot data and TL2 dot data. TL1 dot data is 6 and TL2 dot data is 5. 6 is less than 5? No. So we'll go with the else part, and else part temp dot next equal to TL2. So here instead of 3000, what will be stored? TL2, which is 3500, which is node 5 to 3500, and here 3600. Now TL2 will stop pointing here and it will move to next, which is this one. TL2 will point to here instead of this. And then after that, again we have to move temp. Temp will be pointing to this location. Again, check the conditions. Is TL1 empty? No, it is not equal to null. Is TL2 equal to null? No, it is also not equal to null. Then what we need to do? Again, TL1 dot data, which is 6, less than TL2 dot data 7. Yes. Then temp dot next equal to TL1, which is 3000. So I'll add the node here. Instead of this, I'll add 3000. So it will point to node 6. And after this, it is having null. Right. And also another thing we need to change, which is temp will stop pointing here and temp will point to here. Okay. Now again, TL1 should be changed to the next one, which is null. So now TL1 will point to null. Again, we'll check the condition. TL1 not equal to null. No, this condition is failed here. So we'll come out of this while loop. After coming out of this while loop, if you observe that we have this 7. So what we need to do with this? We need to add it, right? For this purpose, we don't know how many elements are there after this. Sometimes it might be in list 2 and sometimes it might be in list 1. So we have to write both the conditions. So here what I'll write, if TL1 not equal to null. So if there are elements in list 1, then what I have to do? Temp dot next equal to TL1. And if TL2 not equal to null, then temp dot next equal to TL2. Okay, after this while condition, when the linked list 1 has elements, all these will be added. And if L12 is having elements, and if linked list 2 has elements, it will be added. Okay, so here we'll again check it. Is TL1 not equal to null? No, it is equal to null. Okay, so condition not satisfied. Then what is the second condition? TL2 not equal to null. Yes, it is not equal to null. So temp dot next, that is in this location, we will add TL2. TL2 is pointing to 7, right, which has address 3600. So here directly 3600 will be added, so 7 will be added. And if there are other elements after this, they will also get added because there will be a link. But here after 7 no elements are there, so it will keep nothing. Or if in some case there are elements here, like after 7 we have 8, 9, then it is at location 40. Just assume that there can be present at any location. So 40, 50, and then null. Then because here after 7 what we will store, 40 will be stored, right? So here obviously 40 contains 8, so when we are checking it will go to 40th location and we will found 8, and its next is having 50, so we'll go to 50 location and we will find 9. Okay, and here the issue is I didn't mention all the nodes that are present because you will get confused. So, but if you go internally, if I go here, previously it was 3000. Let's assume that. So if I check 3000, all the elements that are after the linked list, we can access them. But here, but it is getting modified to 2000 after some time when we are not checking. So that's why we can get the proper answer. Now let's take some time to analyze this code and understand. After that, we can go into the coding part. We will open LeetCode and we will proceed there. So here we open the LeetCode, and if you observe the linked list class, it has value and next. And the linked list class name is list node. First, I have to create a list node dummy, and it should be containing any -1 or 0. So here I am giving -1. After this, I have to take another temporary variable. So list node temp equal to dummy. Okay, then I have to start writing while TL1 not equal to null and TL2 not equal to null. Before taking TL1 and TL2, I have to declare them. So list node TL1 equal to list1, list node TL2 equal to list2. That's it. And after this, I'll check the condition. If TL1 is less than dot data is less than TL2 dot data, then what I have to do? Temp dot next equal to TL1 and TL1 equal to TL1 dot next. And if it is not the case, TL2 temp dot next equal to TL2 and TL2 equal to TL2 dot next. And in both the cases, temp will be moving forward to the next node, temp equal to temp dot next. And then we have to return the head, right? So see here, if I have to return, what elements will be returned? -1, 1, 2, 3, 4, so on, right? But here the question is, can I return -1? No, right? So here I need to modify something because this can't be returned. This is dummy, right? Which is our head node for the merge. So what I'll do here? I'll return simply 15,000. So what I'll do here? I'll simply return from 1500, which is dummy dot next. So same thing, I'll proceed there. Okay, after this, what we need to do? We have to write the if condition. If TL1 not equal to null, then temp dot next equal to TL1, and if TL2 not equal to null, then temp dot next equal to TL2. That's it. After that, we simply need to return dummy dot next. Now let's run and see. Okay, thank you everyone for watching this video. All the materials that we used here will be linked in the description, and the code will be available in the description. Thank you for watching.